Hello everyone, welcome to this session. Our chapter is waves, and today let's discuss about the propagation of the waves. So far in our previous video, we covered up the various behaviors of the waves, which are the diffraction, reflection, and interference. We also their applications. So today let's move on to the propagation of the waves. Specifically, we will discuss about the propagation. We'll start with the propagation of the mechanical waves. So the propagation is simply just the way in which the waves travel. So we'll start with the way in which the mechanical waves, how they can travel. Now, the mechanical waves, they can be divided into three main categories according to the ways in which they travel, known as the propagation. So the mechanical waves can be divided into these three main categories in a way because of the way which they travel according to from one place to another through maybe kinds of various medium. So we'll get the three kinds of propagations of these mechanical waves. So the propagation of mechanical waves. So the three propagations of the mechanical waves. There's four. We start with the first one, that is the transverse wave. Uh, a transverse wave, this is the one that vibrates at 90 degrees to the direction of the wave, which is moving. So this is the first propagation or the movement, and you can classify it as a transverse wave in a way that there's a vibration of 90 degrees to the direction of the movement of that kind of a wave. For example, if you hold a string between two hands and shake it up and down, you get a wave that moves along the sling, but the vibration will still be up and down, and you will see how you can see it through a sling. And the other example is the underwater waves, which they are also transverse waves. So here is how it looks like for the first example. So a sling will just see the movement or the motion of the wave, and according to these kinds of the vibrations. So these are just the transverse waves. Moving on, the second propagation is a longitudinal wave. This is the one in which the vibrations are just parallel to the direction of the wave which is moving. That's like sending a pulse along the length of a sling, pushing it lengthwise. So that's how it looks like, the longitudinal wave. Instead of peaks and troughs, longitudinal waves, they have compression, whereby these are just areas where the sling is bunched together, and a layer fraction whereby the sling is spread apart. And this is how it looks like for this slick example, whereby the vibration might look like in these directions, and the motion also will look like in this kind of a direction. So that's longitudinal waves. Longitudinal waves, another example of longitudinal wave is the sound wave. Although you cannot see the air molecules, if you could, you would notice that the sound, it involves air molecules hitting each other, thereby producing the areas with high densities of the molecules by this compression, and areas with the low densities of molecules by the layer fraction. So longitudinal waves, you can have these kinds of example, the sound waves, briefly explained in this way. When if it would be possible to see, if it would be possible to see the sound waves, that's what it happens in the sound wave. The other propagation of the mechanical wave is a surface wave. This is the kind of the wave that travels along the boundary between the two materials. From the word the surface wave, it means like it's kind of a wave that travels through the surface, or just the upper surface of the given material. So it's that kind of the wave that travels along the boundary between the two materials. For example, the kind of the water wave you often see along the top of the water is just an example of a surface wave. Surface waves, they move in similar ways to the transverse waves, but they are a bit more complicated in their behavior, as in a way that, as you can see here, this is the example of a surface wave, that is the water wave. As you can see, this kind of wave that acts on the surface of the material in the surface of the water. The surface wave also, in case of the earthquake, you can get a mixture of all these three types of the waves. the longitudinal, the transverse, and the surface waves. The initial earthquake, that is called the primary wave, is what we call the longitudinal. But the aftershock that comes later, that is called the second wave, and it is transverse wave. So that's example on how you can see the earthquake, the various waves that can be seen there. The exosurface waves are also created during the earthquake. Now let's see the propagation of the electromagnetic waves. So we've seen the propagation of the mechanical waves. We've seen they can result to three kinds of propagations according to the way in which the wave travels. So let's see how the propagation occurs in electromagnetic waves. We'll briefly see it that the electromagnetic waves, they are only the transverse waves. So the electromagnetic waves are generally the transverse waves. The velocity of all the electromagnetic waves is equal to the velocity of the light, that is 3 times 10 raised to 8. So that's the velocity of all these electromagnetic waves. The electromagnetic waves, they just do not need medium for their transmission. Compared to the way when we were talking about the mechanical waves, whereby they require some kind of material or medium transfer, or just to move just for the wave to travel from one place to another. The electromagnetic waves are just arranged in special arrangement that is known as the electromagnetic spectrum, according to the increase in their frequencies and decrease in their wavelengths. So that's how the electromagnetic waves are arranged. They're just made or put in a form in a special arrangement that is known as the electromagnetic spectrum. So this electromagnetic spectrum is just the crucial special arrangement or putting together of these electromagnetic waves according to their increases in their frequencies and also decrease in their wavelength. So that's all about the electromagnetic waves. So that's all I have for this session of the screen one. We've seen the propagation of the waves, we've seen the propagation of the waves in the mechanical and the electromagnetic waves. Thank you.